All right, sometimes we make mistakes. Isn't that true? That's sad but true fact. Sometimes we make mistakes. And so we can make errors in hypothesis testing. And that's true with our confidence intervals too. Remember when we do a confidence interval, it's 95% of the time it's working, right? Which means 5% of the time we don't capture the true population mean. Well, we can make errors in hypothesis testing too. So even though you do all the process right, all the setup right, you could still just happen to come to the wrong conclusion because you got maybe some unusual sample, okay? You get some unusual sample. And so there's two kinds of errors though, okay? Two types of errors. So it's possible that when you reject HO, the null hypothesis, you could reject it when it's true. Whoops. It was true, but you said reject. Or the opposite, right? It could be false, but you didn't reject it. And so these are these two types of errors. This is something you actually need to memorize, okay? So this true-false thing. Okay. So let's see if I can set this up here. Let's just say the null hypothesis is true and you fail to reject. Well, let's just say you reject it. Let's say you reject it versus fail to reject. Okay. If it's true and you rejected it, whoops. Okay, that's a type 1 error. This table helps people sometimes, by the way. Let's say it is false. It's false and you reject it. You made the right decision. Good job. That's where we did not make an error. Okay. Now let's say it's true and we fail to reject it. Well, that's correct. You don't want to reject it if it's true. So we failed to reject. It's true. We made the right decision. Okay, but if it's true and we reject it, we made a type 1 error. In fact, I won't write the number 1. This is supposed to be a Roman numeral 1. Okay, type 1 error. Okay, now let's say it's not true. It's false, but we didn't reject it. We failed to reject. And it's false, meaning it's still sitting there. That's not proving it. It's not making any kind of proof. So what we'd say is we've made a type 2 error. Oftentimes we don't really know. Okay, we don't really know if we've made one of these errors because we follow all these procedures. We're hoping it's right. And so what happens is we get in this thing called this level of significance. Also true, like we had a confidence level. We also have this level of significance called alpha. And it's also usually around, it's also based on that 95% confidence level usually. And so the chance of making that error, the chance of the type 1 error is given by the symbol alpha. It's called the level of significance. And then, so like if you have a 95% confidence level, you would have a significance level of 0.05. So like 1 minus the confidence level is alpha. Okay, so alpha is the difference there from 100% to whatever percent you're working with. Now, the chance of a type 2 error also gets a nice Greek letter beta. Okay, so alpha and beta. So the probability of a type 1 error, sometimes you'll see it written like this. Probability of type 1 error equals alpha. Okay, and probability of type 2 error equals beta. So you'll see that. Okay, here's an example. The 8 minutes after a medical emergency is a key time to start delivering medical help. Last year, a paramedic team at a hospital arrived on the scene of an accident 75% of the time within 8 minutes. The city manager wants to determine whether they've done better this year, okay? So we have to think better. Was better going to be greater than 8 minutes or less than 8 minutes, right? Okay, so they take a random sample of their arrival times to study this. And here's what they find. There are 4 questions you want to be able to answer. What are the null and alternate hypotheses? What would a type 1 error mean? What would a type 2 error mean? And what are the consequences of each? Which one is a more serious problem? Okay, so here are our answers. So, okay, we're saying 75% of the time we're under 8 minutes, right? But what we're hoping now is that this is happening more often. So we're saying that the population proportion of what? The population proportion right, of proportion of the paramedic teams that arrive on the scene of an accident is less than 8 minutes, right? That's our population proportion. Okay, so it's 75%. We're actually hoping that this is increased. So our null hypothesis is that it hasn't, or that it's 75%, the historic value. And we're trying to reject that. We're trying to say that it's increased. Okay, so the type 1 error here. All right, so again, let's say that this is true, but we reject it. We conclude that this is true. So the proportional arrival times is equal to 0.75, but you rejected that and concluded that it's more than that. Okay, the type 2 error is going to be the opposite, right? So the type 2 error is going to be that this isn't true. It has increased, but we failed to reject it. So we don't think that this has happened. And so it's actually greater than this, but you failed to reject it. You didn't get significant enough evidence to make that conclusion. Okay. Okay, so that's a type 1 error. What does it mean? What does it mean? So just direct interpretation. Now, what are the consequences? Well, if that happens, you think you're doing better than you actually are, right? And you're patting yourselves on the back unfairly. Type 2 error, you're actually doing a better job than you realize, all right? And so you think you are versus you actually are. So each one of these are just incorrect. We just don't have the correct information. Okay, now for a part D, which one is more serious now? So let's just say you think you're doing better than you are, but you're not. If you have a type 2 error, then you're just going to try harder. So that's not bad. That we may see that we get an even better result next time, right? So you're going to try harder. That's a good thing. But if you have a type 1 error, then you're going to feel like you can relax a little bit when actually you can't. Okay, so you're not doing as well as you think. And this can have some consequences, right, for people's medical situations. All right, so this is really important. These types of questions, defining null and alternate hypotheses, interpreting what they mean, and then putting it into context. So like, what are the consequences? Well, you're wrong, right? You're wrong here, or you're wrong here. So putting that into context a little bit. Notice that for part B, where it just says, what does it mean? It's a little more statistical language here. So it's just saying the proportion of arrival times is equal to this versus, versus what you rejected it. Okay, so using that test language as opposed to interpreting it into like common words. Okay, now, but then this last part here, when we're really talking about the seriousness, there's a little bit of a judgment problem there, a judgment issue there. You have to really think about it and really decide which one you think would be more serious. Okay. Now, last thing about this is we often get to choose an alpha level. And so when you're doing hypothesis testing, they'll say that the chance of a type 1 error alpha is under our direct control and is often chosen to be at 1% or 5%. Okay. Notice this is the same as the 95% confidence interval. So when we're 95% confident, we're saying 5% of the time, actually, we'll be making a mistake. Okay. So again, Mr. Simon, right? Why don't we always pick alpha to be really small as we want? Well, because it means you're going to have a larger chance of the other problem and vice versa. So we're trying to balance out the probability of these two types of mistakes. Okay, so we're making this trade-off. All right. And we want to choose an alpha that's going to shrink whichever error we think is more serious. So this 0.05 is really common. Okay, and so that's what you should always use if you're not sure which one to use. But remember, if the beta is going to have a more serious consequence, you may want to choose a larger alpha. Okay, so that you can minimize beta. Okay, we'll talk more about that in class.